Welcome to the Christmas Sky Notes. I thought I'd start with this picture, which is, I think, really nice. This is a picture of an aurora taken by Gordon Mackey from right up at Dunnet Head, is right at the top end of Caithness. And here you've got this nice faint aurora here with the lighthouse in front. Thought a very nice photogenic picture. Before I do anything more, though, in terms of what we're going to see in the sky over the next few weeks and months, I thought I'd actually show you a couple of pictures of something you may see going around on the internet. If some of you are looking at the internet this morning, there were reports of a bright comet being discovered in the sky, and this comet was described as being as bright as Hale-Bopp. And moving across the sky quite slowly. In fact, even inexperienced observers described it as that. It actually was the result of this. This is a launch of an Atlas Centaur rocket from Vandenberg in California at 19 minutes past 3 this morning. And on top of this rocket, the second stage, the Centaur stage, goes into to orbit with the spacecraft, and it goes into a very long looping orbit called a Molniya orbit. So it's moving very slowly across the sky. It was predicted that this would become visible from Europe around 4:30 in the morning. And another thing that was predicted is that in order to avoid the possibility of this Centaur stage exploding and breaking up in orbit, they dump fuel from the Centaur stage. So very rarely we have the opportunity to see a fuel dump from a Centaur, and that's exactly what happened this morning. So some people who either knew that this was going to happen or were lucky enough to be outside observing saw this. Now you can believe that that might be a comet. I was actually up in my back garden at 4:30 this morning hoping to see this, but unfortunately where I was in Chelmsford it was cloudy. But this is a really nice picture taken by William Stewart up in Cheshire, and I know quite a lot of people saw this. It went round a lot on Facebook this morning as well, and just a good demonstration you can't always believe what you read on Facebook. So if anyone says to you, what's this about this bright comet that was discovered in the sky, you'll know what it is. It was a fuel dump from a Centaur upper stage of an Atlas launch of an American spy satellite. So this is classified. You're not supposed to be able to see this. Okay, back to a bit of astronomy then. So we start at the centre of the solar system with the Sun. The Sun's been reasonably active recently. This is SOHO white light MDI image from yesterday. Quite a few groups, but they're all relatively small, nothing like the very big sunspot group that we had at the end of October, which I know a lot of you saw. But those small sunspots have been leading to some auroral activity, generally in the northern extremes of the British Isles. And Denis Brzezinski, who actually has an observatory up at Port Mahomet, which is right up the north coast on the Moray Firth, sent me this lovely image of an aurora. And he says he gets these quite often. They're effectively light pollution as far as he's concerned. So moving a bit closer, but to the next brightest thing in the sky. This is the moon, of course. Anyone like to guess who took this image? Yes. Too easy. But yeah, this is one of Damien's images. He collected terabytes of data earlier in the year, and he's been gradually trudging through it. And a couple of weeks ago, he sent out an email with links to all of his lunar photos, so it's worth going to his webpage and having a look. We heard the Astronomer Royal talking about the Apollo astronauts earlier. I think this is probably what Mike Collins saw from the command module when he was going around the moon. It's that kind of resolution. Quite amazing stuff. So in terms of what the sky's like at the moment, as it gets dark, about now, in fact we should all be outside observing the Geminids because it's lovely and clear outside at the moment. Over in the east we've got Capella rising, Auriga and the constellations of Winter rising in the eastern sky. And in the western sky we've got a few of the sort of summer constellations still there but gradually getting lower. And two interesting objects. One of them is the planet Mars, which is not so interesting at the moment because it's a long way away. It's moving towards conjunction next year. But one particularly interesting object that the variable star observers will be raving about is this object, R Corona Borealis. R Corona Borealis is a variable star that sort of is an upside-down variable star. So it's normally a binocular object. Every now and again, it gets enveloped in dust and it disappears. And so R Corona Borealis actually has been in a faint state for quite a long time. But it's now brightening up again. So just as it's kind of disappearing from view into the sun, it's brightening back up again, and people are beginning to see it in binoculars again. It's been down very faint, so you'd need quite a large telescope to see it, and it's now brightening up. And here you can see the light curve. So here you've got it down at about 15th magnitude. It's kind of had a few fits and starts at trying to come up, but it now really does look like it's back on the road to its normal brightness, which is normally up here around sort of 6th magnitude or so, so just on the verge of naked eye. So there's not really much to say about Mars. It's a long way away, not much to see on its surface, but this was an interesting event that occurred earlier in the year. This was in October, and this was the comet 2013A1 Siding Spring that actually made a very close approach to Mars. And this is a nice picture that Martin Mobley took of the comet, and here's Mars pretty much overloading the picture. That comet went very close to Mars, and all the spacecraft around Mars pointed their cameras at it and took images. But of course we've got a number of spacecraft on the surface of Mars, and the Mars Curiosity rover is still trundling around taking extraordinary images. And I just thought this one was amazing. So this is an image from the surface of another planet. This is an image from the surface of Mars taken by Curiosity, and any geologists in the audience just think, you know, it looks so Earth-like. It really does. So these are sedimentary. Yes, it does need a scale, I suppose. These are fairly close. These are fairly close to the rover. Unfortunately, there was nobody there to stand in front of them to give scale. But it's just these are beautiful sedimentary rocks on the surface of another planet, and we're just so lucky that we've got these things trundling around, and you can go to the JPL website and you can download these pictures day after day and just follow the progress of this wonderful rover trundling around Mars. Okay, moving to planets a lot further away. Uranus is currently in Pisces. It's still reasonably well placed in the evening to observe. And here are a couple of CCD images of it. You can see the belts, and here's one of Paul's drawings. Again, you can see the belts. I don't think there's very much going on Uranus at the moment, is there, Paul?
A couple of storms that have not been observed before, nothing major.
All right. So there is something going on. So anyway, Uranus is definitely worth keeping an eye on because of these wonderful storms that are going on it. Later on at night, of course, we've now got the winter constellations with Orion high in the south, a constellation that pretty much everyone can recognize, and an interesting variable star stroke deep sky object. So this is one of those crossover objects which crosses over from the kind of boring point-like variable star object to something that's a bit fuzzy. and earnest variable star observers can observe this because they're getting science from it, and deep sky observers can observe it because it's deep sky. So this is RR Tauri. It's one of these variable nebulae. So it's a variable star that's associated with a nebula, and there's a project currently going on which is a joint deep sky section variable star section project. So speak to Callum here if you're interested in doing that. And basically following this object. This is one of Callum's images taken with one of the eye telescopes. Is this New Mexico, I guess? So this is one of the nice corrected Dall-Kirkham telescopes that Eye Telescope have got that you can use online if you're a member of the Eye Telescope group. So looking south in winter, we've got the constellations Orion here, but Of particular interest at this moment and this weekend is the constellation of Gemini, because just around here at the moment we have the radiant for the Geminid meteor shower, which is going on right now, right outside, and the peak of that shower is tomorrow morning. So this is actually an earlier one. This is an Orionid. Just show you that you can get nice photos of meteors using DSLR cameras. Just set the camera up with a reasonably wide-angle lens. Maybe use a shutter duration of 30 seconds, a minute, or whatever you can do in your environment, and a fairly high ISO rating, and hopefully you'll get a nice object. And certainly tomorrow morning, the weather forecast is quite good for the Geminids. So I'm expecting all of you to be outside at 3 o'clock tomorrow morning, observing and counting meteors. So this is where the radiant is. It's just north of Castor. And just in case you don't want to be out at 3 o'clock tomorrow morning doing proper observing, we've set up a scheme on the BAA website where a couple of my video cameras that I use for meteor orbit determination are doing a live feed into the website. So you can go to the website and you can actually have a look at a few recent Geminid images. I had a look at mine just a couple of minutes ago, and it's a lovely clear sky out there at the moment. Now, one of the problems with these images is that the software that detects them basically is looking for movement in the sky. So it detects all sorts of things. It detects aircraft, birds, the Essex police helicopter, Chinese lanterns, anything. So if you actually look on these pages, you'll find there's actually quite a lot of chaff, a lot of things that aren't meteors. So what we're asking people to do is, if you've got a login on the website, and if you remember you should have, you can go along and you can help us by just doing a thumbs up and a thumbs down on the images, and that'll then promote the ones that are real meteors to the top of the list, so that when people come to our site from Facebook or wherever, they'll actually see Geminid meteors and not the Essex police helicopter. So that would be good if you could help us with that. Just a few examples of Geminids from this morning. Of course, the moon was around this morning, and where I was in Chelmsford was quite cloudy, but a couple of nice ones. Nice bright one there, nice bright one there, even brighter one. And yeah, so that's the Geminids. Good over the next few days. Probably the best shower of the year from a dark site. The moon's reasonably out of the way until sort of small hours of the morning. You should be able to see maybe up to even 100 meteors an hour. That's the zenithal hourly rate of the Geminids. Probably the best shower of the year. There's a couple of other showers coming up. One is the Ursids, which is actually visible over the Christmas period, and then the other one is the Quadrantids, which is visible in early January. And this is a particularly under-observed shower because it occurs in an even colder time of the year than the Geminids. But if you're stuffed full of Christmas turkey and you've got through New Year's Eve and you want something sort of worthy to do, get out in the morning or morning of the 4th of January and have a look for some quadrantid meteors as well. Planets, well, Jupiter is coming up to opposition on February the 6th. It's currently a very bright object late evening. And this is another nice drawing by Paul, south at the top in this particular drawing. Naturally. And then, of course, this is an image by Ian Sharp where Jupiter is turned on its head and has got north at the top. Ian has, I think, moved to Spain for the winter, and he's imaging Jupiter from there. So this is not particularly brilliant. Seeing wasn't very good. This one's quite a lot better, showing quite a lot of detail in Jupiter. So then later in the night we get round to Saturn, which is just rising now. It comes to opposition May the 23rd next year. Saturn's actually getting further and further south in the sky. So observing it's going to become more and more difficult from here, but still an excellent planet to observe. But there haven't been many images so far, this apparition, so I thought I'd show this, which is an image from Cassini. And I think this is just an absolutely gorgeous image. So this is as Cassini's going through the ring plane. You've got a moon there, I think it's Tethys, I think I remember. And then the shadow of the rings on the globe. Just an absolutely awesome image of an incredible planet. Looking forward to January. In mid-January, we've got a good opportunity to see Mercury. Mercury will be low in the evening sky, and something worth looking out for in January, one of our best opportunities next year to see Mercury if you've got a good clear southwestern horizon. There are a couple of good asteroid occultations to look out for in January as well. This particular one is one that's got a very large magnitude difference. So this one is on, was it January the 11th? And it's basically an 8th magnitude star, 2 seconds long, with a 7 magnitude drop. So a very obvious drop. It's got a nice track that takes it across a large part of southern England. So definitely one to put in your diary if you're interested in seeing an asteroid occultation for the first time. This is a potentially good opportunity to do that. And then actually on the next morning, there's another one. So this is one for Dennis up in North Scotland, with another quite good opportunity to see a large duration. This is only 1.5 mags drop, but it's quite long duration, 18-second occultation. Something else worth potentially looking out for is this one. This is what's called a potentially hazardous asteroid, asteroid 357439, that is going to make a close approach to the Earth on the 26th of January. It's 650 meters in diameter, so this is quite a big object. It's not going to hit the Earth, and it's not going to hit the Earth at any time in the future that we know of, but it's potentially hazardous, which means that it could in the far future. It's actually passing quite close, only 1 million kilometers away, so about 3 times the distance of the Moon, and it gets to about 9th magnitude. So this is an opportunity potentially to see a 650 meter diameter asteroid with a pair of binoculars. But definitely worth looking out for on the night of the 26th. It's moving quite rapidly north, so it starts off in Puppis, goes through Monoceros, Hydra into Cancer through the night. So you can see here the declination's going from south quite rapidly north. It's well placed. It's effectively going to be at opposition when it has the close approach, so it's well placed for us. So if we get a clear night on the 27th of January, because it's 26.7, we should see this. And this is probably something we'll try and do a BAA live event for, so we'll try and get a feed from a telescope and put it up on the website so you can watch it moving past if you don't go out and see it yourself. Right, okay, so I was going to take a brief interlude just to talk about this. I'm sure everyone's heard of Philae and Rosetta. I actually, at the last BAA meeting, gave a brief talk on the landing of the Philae spacecraft and what needed to happen for it to be successful. And one of the things that I said was that the landing, which is being shown in this nice little animation here, depended totally on the accuracy with which the Rosetta spacecraft effectively released the Philae lander. So it was like almost like a dart player throwing the dart out. The dart, or Philae, has no control over its trajectory, and so the Rosetta spacecraft needed to release it at exactly the right direction and at exactly the right velocity, so that as the comet nucleus rotated underneath, Philae came down at the place they wanted it to come down. And they were incredibly successful at doing that. The estimate of where Philae landed on the comet is that it landed probably within 20 meters of the center of the error ellipse, which is pretty impressive. And given they'd gone to all the effort of selecting that landing site, it would have been great if it had actually stayed there. But as we all know, it didn't. Here it is, fantastic picture, the Philae spacecraft as released from Rosetta. This is taken by the Osiris camera on board Rosetta itself. So this is showing the Philae with its legs deployed and a couple of the antennae sticking out as well. So it went down to the comet. It was moving at about 1 meter a second. It fell from about 25 kilometers up, and this was taken from about 20 meters up by a camera called Rolis, which was one of the downward-looking cameras. So this is a little, well, quite a big boulder on the surface, but you can see quite a nice flat landing area. Unfortunately, before they'd even released it, they knew that one of the things that was going to be used during landing wouldn't work, and that was a thruster on top of the spacecraft, which was called ADS, the Active Descent System, and that was to push the spacecraft down onto the comet whilst the harpoons fired. That wasn't going to work, so they said they'd go anyway without it. It looks like the harpoons didn't work either, and so what happened was Philae landed on its legs at about just under 1 meter per second, and this shows the computer animation of what was supposed to happen. Those legs were supposed to absorb the shock. A thruster on top was supposed to fire to hold it down, and some harpoons would then put it on the surface. What actually happens is the legs absorb most of the shock, but not all of it. The harpoons didn't fire, the thruster wasn't going to fire anyway, and so Philae headed off again at about 0.4 meters a second upwards, which doesn't sound like very much, but the escape velocity on the comet at that point was probably something like 0.7 meters a second. So this was getting on for 60% of escape velocity. Anyway, it did a big hop, and the OSIRIS camera managed to image it on its hop. So this is coming in. These are enlargements of each of the things coming in. It landed perfectly at this point, and then ended off going up over here, and you can see this is an enlargement of it just disappearing off the image here. So the initial landing was in exactly the right place. It then bounced quite a long way, probably about 1 kilometer from where it was supposed to land. Nobody quite knows where, but there's a reasonably good idea where it ended up. This is the incredible picture that the Astronomer Royal showed earlier. This is one of the pictures from the SIVA cameras, one of the panoramic pictures, showing the footpad, one of the footpads of the lander here, and this which was known as the cold wall. So essentially our little Philae bounced across the surface and ended up in a very dark, shadowy, cold place up against a steep slope. And a consequence of that was it wasn't able to charge its batteries, so the solar panels that it had to charge the batteries didn't receive enough sunlight, so the batteries effectively ran down as predicted over 3 days. So the mission lasted for 3 days, which was the primary mission of the spacecraft. And there is a remote possibility that as the comet comes in towards perihelion next August and it warms up and the sun aspect angle gets better, that Philae may wake up. It was an amazing achievement. I think I was amazed by how much interest there was. Where I work in Chelmsford actually, the local newspaper, as local newspapers always do, was kind of talking up Chelmsford's involvement. So the work that I do on the ground station was reported, the work that E2V do, because they made the camera chips. But until I actually saw the local newspaper, I didn't realize that Chelmsford also had another connection to Rosetta. And those of you who have seen the ESA coverage would have seen the chief scientist at ESTEC, a guy called Matt Taylor, who is going to be at Winchester. So I strongly recommend that people book for Winchester. Matt Taylor's a good guy, but he got into a bit of trouble for his shirt. And it turned out that his shirt was made in Chelmsford as well. So anyway, Rosetta is still following the comet in. Perihelion's next August. These are some of the NavCam pictures. I've mentioned before that the OSIRIS camera, which is the camera that gives us the very best images, the images are proprietary on that, so the principal investigators don't release many of them because they essentially want to have the first chance at doing the analysis, which is quite reasonable because they put an awful lot of effort into getting the camera funded and making it. But it does mean that we have to make do with second best at the moment, but they're not bad. So these are NavCam images, and the comet is now becoming quite active. So this is end of November. You can see quite a lot of jetting activity coming off that. So we've got an exciting time over the next year or so just watching this comet switch on as it comes in towards the sun. From our perspective, we'll get a chance to see this comet probably after perihelion, September next year. It's not going to be very bright though, sort of 11th, 12th magnitude if we're very lucky. So it's a telescopic object, but something I think a lot of people will be trying to image just because Rosetta is there going around it. So just a quick final summary of other things in the sky. We've got a possible Christmas comet. This is Comet Lovejoy. At the moment it's fairly far south, but it's coming north, and it'll be a binocular object in early January. So if we're lucky, it could be quite a nice comet, certainly something for binoculars or DSLR images. And it's quite well placed. It's going through Lepus up into, eventually into Andromeda, and then up into Cassiopeia in March, although it'll be a lot fainter by then. A few other things quickly. Hazel mentioned it earlier. This is something that Dominic has done for us. This is a YouTube video, Best Amateur Images 2014, that have been submitted to the BAA. It's a really nice, well-produced video that just shows what amateurs are able to do these days in terms of imaging. Some really nice images of all things from planets through to deep sky. Go to YouTube, have a look at that. Definitely worth looking at. And of course, one of our images is in the audience. He got the Patrick Moore Prize earlier today, Cameron. And just thought I'd show you a couple of Cameron's pictures. Now, these are actually not the best. Cameron showed me a few more on his phone, but I haven't got them in here. So I would say that these aren't bad. So this is M27 in Vulpecula, and then this is Pacman Nebula in Cassiopeia. So again, a good example of what you can do these days with sort of reasonable equipment. So DSLRs and small refractors. Yeah, one thing before we close, and this is to check to see how many people actually read their journal. And this is something that Cameron might like to learn as well. So one of the big problems that imagers have these days, well, has always had, is that your corrector plates get really nasty and dirty, and you need to think of ways of cleaning them. Now, who's read their December journal and knows where this is going? And who's tried it? Okay, so Ron Arbour is one of our very best observers, and he's also one of our most ingenious observers when it comes to telescopes. So he took his corrector plate from that to this. Now, what amazing technique does that? This. So, as it says in the journal, you do this at your own risk. But Ron is a very experienced observer. I have actually tried this on not on my main telescope, but on a test piece of optics. And the key thing is this has got to be proper sellotape. Don't use cheap substitutes. Don't get your stuff from Poundland or whatever to do this. This needs to be proper sellotape, and it needs to be new. But it looks like it works really well. So I'll be interested to hear if anyone tries this, but you do it completely at your own risk. The BAA accepts no responsibility whatsoever.
Nick, can I offer one word of warning?
Only one?
There are two types of coatings, and most are hard and they bake on, and that's expensive because they can crack. So some manufacturers, in particular the Russian Maxutov, they use a soft coating on the meniscus lens because they don't want to risk cracking the expensive meniscus lens. So I just think, and I've seen a lot of soft coatings on Russian meniscus lenses rubbed up when people clean them because they're very soft and delicate. So I just wonder if that might be fine for an SCT where they bake it on, but on a Russian mic, you might just find you set the coating off. Yeah,
I think you're absolutely right, Andrew. I mean, I tried this, and it does say try it on an inconspicuous part of the optics first. Anyway, so if you get a telescope for Christmas, this is always a possibility for what to do. But thank you very much for listening. I hope you've enjoyed today. And